All right, so in this video, we're going to look at finding molecular formulas from empirical data. This is a three-step math function, so it is easy as 1, 2, 3. So here are the steps. You need to mass the empirical formula, and in order to do that, you're going to use the periodic table. You need to divide the experimental mass that's going to be given to you in the problem by the empirical mass that you're going to find, right? When you divide those two things, you're going to get a ratio, which we call the mole factor. And the last thing you're going to do is just multiply that factor times the subscripts of the empirical formula. So it's pretty simple, pretty straightforward, actually. So let's look at one of these. It says a given compound with the empirical formula of CH2O has a measured mass of 60.06 grams per mole. What's the molecular formula? Well, our first step is to mass the empirical. So we have carbon, which is 12.011 grams from our periodic table. We have two hydrogens, so that's 2.016, right? And in order to get that, we need 2 times 1.008. And we have oxygen, which is 15.999. So I'm going to add those things up. Let's see here. Of 0.011, 2.016, 15.99. That gives us 30.026 grams. That would be per mole. So this is the mass of our empirical. We have a measured mass or an experimental mass. And so our step tells us that we do experimental divided by empirical. So 60.06 divided by 30.026, which we can round to 3, is 2. Right? 60 divided by 30 is 2. So here's the easy thing about this. This number right here has to be a whole number. N must be greater than 1, right? And it must be an integer. So it can't be a decimal. Now, if you get like 2.00 or 1.999, okay, round that to your whole number. But in essence, it has to be an integer. The last thing I'm going to do is take that 2 and I'm going to multiply it by these subscripts in my empirical formula. So I'm going to do C1 times 2, H2 times 2, and O1 times 2. And that's going to give me C2, H4, O2. And there's my molecular formula. Remember, molecular formulas are not reduced. Empirical formulas are reduced. All right, that's something you want to keep in mind. Let's look at 2 more. So I have the empirical formula of P2O5 and a lab mass, so a mass that we got during an experiment of 283.89. Find the molecular formula. All right, same thing. Phosphorus, let's look up phosphorus, is 30.974. 30.974 for phosphorus. We have 2 of them, plus 15.999, and we have 5 of those in oxygen, right? So P2O5. So we punch that in the calculator. That gives us 141.943, so 141.943 grams per mole. There's the mass of our empirical, so 283.89 divided by 141.943. We should get about 2, but let's see exactly what we get. 283.89 divided by that number is 2.00002818. Yeah, we can definitely round that to 2. Now again, we're going to multiply. P2 times 2, O5 times 2. We're going to get P4, O10. There we go. Molecular formula. 3 steps. Last one we'll look at. We have percentages here. So now this question is going to ask you to think a little bit more. It doesn't give you the empirical formula right away. It gives you percent composition data. But we know how to take percent composition and calculate empirical formulas. So let's do that. We have 29.46 grams of calcium. We know that we need to convert grams to moles, so calcium is 40.078 grams per mole. Calcium. All right, we've got 0.74 grams of hydrogen, which we're going to divide by the molar mass of hydrogen. We've got 22.77 grams of phosphorus. Phosphorus is 30.974. Is that right? Yes. And we have oxygen, which is 47.03 grams divided by 15.999 grams of oxygen. So let's run these numbers. 29.46 divided by 40.078 gives us 0.7351 moles of calcium. 0.74 divided by 1.008 gives us 0.7341 moles of hydrogen. 22.77 divided by 30.974 gives us 0.7351 moles of phosphorus. 47.03 divided by 15.999 leaves us with 2.9396 moles of oat. We know the next step is to divide by the smallest number we have, which in this case is 0.7341. And so calcium and so we get 7.7351 divided by 0.7341 gives us 1.00. So we can say 1. Hydrogen, anything divided by itself is obviously 1. Phosphorus, well, it's the exact same number as calcium, so we know it's going to be a 1. When we round it, it's going to get the same thing. And our last number, divided by 0.7341, gives us 0.04. All right, there we go. So there's our empirical formula, CaHPO4. CaHPO4. All right, there we go. We can't stop there. This is empirical. We need to find molecular. So we need to mass this thing. So fortunately, over here, let me switch colors. We've already got the masses off the periodic table. Right there, right there, right. These are our masses. We just need to add them up and multiply. The only one we have to multiply is there are 4 oxygens. Everything else, there's just 1. So we'll do 40.078 plus 1.008 plus 30.974 plus 4 times 15.999. And when we add that up, we get, let's see here, 136.056. There's our mass, grams per mole. We have 272. I think we can all figure out where this is going. 0.112 divided by 136.056, which we just found. 272.112 divided by 136.056 gives us 2 exactly. So we know we need to multiply everything in the empirical formula by 2, and that's going to give us Ca2H2. And we know that PO4 is phosphate, so I'm going to leave phosphate in a bracket and put a 2 outside of it, just like that. So there's my molecular formula. So this last problem combined what we did in the past video on finding empirical formulas with what we did in this video for finding molecular formulas. Don't be surprised when you see those things stuck together, all right? That's not an uncommon problem set, okay? That's all for this video. If you have any questions, send me an email, and I'll be glad to give you a hand.